now we are finding the reciprocal of the function graphically, right? Fx. So see, there are certain rules, however, that we will discuss later, but I'm just showing like graphically how it happens, So see, think like that. If for some value of x and we are getting some value of y, so if this y value is going to be large, is going large, then for reciprocal, in case of reciprocal, the y value is going to be small, right? Y value going to small. Because it's getting reciprocated, Let's say, for example, for x equal to 2, let's say y is 10. Let's say x is equal to 5, y is actually 35. Let's say for x equal to 10, y is something 100. For example, I've just taken some order pairs, and these order pairs are for fx, let's say, okay? So if I'm doing 1 upon fx, then what happened for these order pairs? When x is 2, y is 1 upon 10, which is 0.1.
Okay.
And when x is equal to 5, so y is 1 upon 35, And when x is equal to 100, when x is equal to 10, y is 1 upon 100, which is 0.01.
0.01.
So see, the values are getting small, On the other side, if I'm taking a small values, let's say for some value, let's say 1, let's say y is, it was 10, let's say I'm taking 2. Let's say x equal to 0.5, I'm taking y is, let's say, 0.1. Let's say for x equal to 0.25, y is, let's say, something 0.05, let's say, okay? So I've taken like few other order pairs. So now you see what happens here when we have 1 upon of x. So now for x equal to 1, y is 1 upon 2, which is 0.5. It is actually large and out of the all above values,
Yeah.
And x equal to 0.5, then y is equal to 1 upon 0.1, which is 10. And x equal to 0.25, so y is something 1 upon 0.05, which is what? 100 upon 5, that means 20, isn't it? Right? So it's becoming large. So simply when y is becoming small, I mean the reciprocal of y becoming large. If y is becoming small, then the y of reciprocal is becoming small. I mean, the other way around. Small too big and big too small. That's what.
Got it.
Okay. So this is one important thing. Second thing is what? Wherever fx is 0, where 1 upon fx is not defined.
Is undefined.
Not defined, right? So that become what? Asymptote, So basically the roots, y is equal to 0 means what? Roots become what? Asymptotes. Asymptotes. Which asymptotes? Horizontal. Horizontal. Hope this is clear.
Yes, sir. Very close.
Okay.
Very clear, sir.
All right. Very good.
And roots become asymptotes.
Roots become asymptote. Right. And maximum.
So could you give an example?
I will. I'm coming to that. And maximum point become what? Maximum points become what? Minimum points. Minimum point. And minimum points become maximum points. Maximum, right? So these are few key points basically, And
this is in general, right?
General, yes, of course, that's what, And let's say if we think about vertical asymptote, vertical asymptote. So vertical asymptote is happening when x is at some particular value of x, which is y is tending to infinity, Yeah. So what happened to that? That become roots, So vertical asymptotes become roots or axes. Intercept. All right. Okay, cool. So let's see some simple example, one simple example, then we'll take little complicated, okay? So I'm taking one equation, one coordinate equation. That's a very simple. No, look at this. Over here, we have these two roots, correct?
Yeah,
So
correct.
they will become what? These
So,
will become what?
so roots will remain, roots will turn into, roots will become asymptotes.
Correct. Vertical asymptotes, you know. So I'm making it here, vertical line, and one vertical line. We have got these two lines. No, this is maximum point. So for example, this is something 4 minus 2. I'm taking. So reciprocal of minus 2 is what? 1 upon minus 1 upon, isn't it?
Yeah.
So our vertex will be 4 comma minus half. That is, so it has come here, you know, and our shape will be like this. Look at this, you know, because these are the asymptotes. One more thing you can note down here, you know what? That negative y remain negative and positive y remain positive. No. So see, this is a between 2 to 6 y values are negative, isn't it? So they are negative. The minimum, which is 4 minus 2, become maximum. I can say 4 comma minus 0.5. And to the left side, before minus 2, when x is less than 2, this is the going to be like this, like this. You know, this point is, let's say, 4. So this is 2 and c. And this is what? Going to be asymptote, actually, you know. It's going up and up forever, you know, for infinity. So this is going y tends to 0, you know. So x-axis becomes the asymptote, horizontal asymptote, you know.
Got it.
And similarly to the right side, you see, this is going to be y tends to infinity. It's going to up and up forever, you know. So, so what I can say here, I can make it similarly. I can make it up like this. So it's never going to intersect the x-axis, right? And these points, which are 2 and 6, which were the roots earlier, they are the vertical asymptote x equal to 2 and x equal to 6. Hope this is clear to you.
Okay. So asymptotes, and then I didn't understand one part. Okay, so
Yeah.
The part where it goes to 2 intercept, like
Yeah.
from x equals to 2 on a graph, where from the left hand side.
Okay. Left hand side, yeah. Okay. See, it is the y is equal to 4, right? The y intercept is 4.
Yeah.
So obviously, when y is 4, so reciprocal is actually 1 upon y, you know. So what? We get 1 upon 4.
Yeah.
Oh, sorry. Yeah, 1 upon 4. Sorry. You're right. This is 1 upon 4, actually, you know.
1 upon 4, okay.
1 upon 4. Right? It should be like more like, no. I mean, like, I should make this graph. I can make it here. This like this, you know. Right? So this point is 0.2.
Yeah.
That's the point.
Got it.
Cool. What other thing which you did not understand?
So on the right graph, sir.
Right graph. Okay. So in the right side, you see this is going up forever, right? So let's say for some value of x, y is something more than 100 or 1,000, isn't it?
Yeah.
That's 1,000, you know. So what will happen? This will be 1 upon 1,000, isn't it? Which is 0.001, which is very close to x-axis, isn't it?
Okay.
Its triumph does the x-axis, right? And since at 6 it is 0, so 1 upon 0 is not defined, so that's why it is y tends to infinity at x equal to 6.
Okay.
Right? This is clear to you?
Very clear. Yes, sir.
Okay, great. So we will do like a few more questions. Okay.
Yes, sir.
Mhm.